Hello everyone, this is day 5 of the Quadratics unit, and this day in class we went over one of these examples together, and then the remaining 3 problems were given for everybody to work on in class during that time. So I'm going to do the same thing here. I'm going to give you one of the examples, and then the other 3 are assigned to you for practice. Now you can definitely ask for help in class or shoot me an email if you're not sure on them, but this will at least give you one example to go over from that time that you missed. So the first one is one that we're going to do, and it's in standard form and intercept form. Now, the previous lesson we gave you the x-intercepts. This time we are not. However, this intercept form pretty much hands them to you if you know what you're doing. Now, remember, x-intercepts are on the x-axis, kind of obvious, right? Any number on the x-axis has to be something comma 0, like right here this is -1 0, sorry, this is -5 0, -6 0, that's 1 0, like they all have something comma 0. That means that the y value has to be 0. Well, if that's true, that means that this part of my equation should be 0. So really I'm trying to figure out what do I plug in for x to make this equal 0. So I can actually write it out as 2 separate equations. It's really like x minus 3 equals 0 and x minus 1 equals 0. Again, x-intercepts have a y value of 0. That's why I'm putting the 0 in there. If I add my numbers to the other side, then it looks something like that. So those are my 2 x-intercepts. One is at 3 0, and then the other is at 1 0. So we're going to put 1 3 right there. Okay, so there's our 2 x-intercepts. And you can make some extra notes for yourself if you need to. You don't have to just put what I do. It would be smart to put some extra things to help you explain it to yourself. Now, axis of symmetry means that that's the line in the middle of the parabola. It's the one that reflects over it. It makes it the same on both sides. It's symmetric. So this should be in the middle of the x-intercepts. Well, my x-intercepts are at 1 and 3. The number in the middle is 2, so that's where my axis of symmetry has to go. Like that. It's at +2, but remember we don't just name it as +2, we put it as x equals 2 because it cuts through the x-axis at +2. It's that line. Okay, now the vertex, that line actually really helps me because that vertex has to be somewhere on this line. Well, every point on this line has something in common. This is 2, 1, 2, 2, 2, 5, 2, 10, 2, -5. They all have to be 2, something. I just don't know what the something is. Okay, well, if I know that 2 is the x value, by the way, it's coming from this. If the axis of symmetry is 2, the vertex has to have an x value of 2. Okay, well, I can figure out the y value kind of the same way I thought through this process, except this time I'm not plugging in for y, I'm going to plug in for x, because this is what x equals in this case. I'm trying to find the y value for that one. So instead of x here, I'm going to plug in 2 minus 3, and multiply it by, instead of x, I'm going to put in 2 and then -1. I'm really just replacing these 2 x values right there. That's it. 2 minus 3 is -1. 2 minus 1 is 1. Multiply those together and I get -1. So there's my vertex point. 2, -1 right there. And then I can draw my parabola through. All right, so that's really all it takes to be able to draw this from your intercept form. If they hand that to you, it's just a matter of pulling those numbers out. You know that they have to make 0, So really, you're kind of taking the opposite. 3 minus 3 is 0. 1 minus 1 is 0. Now, this last part that they're asking you to solve for, rate of change, is really just a fancy word for slope. And you might want to make a note of that to yourself. Remember, slope is rise over run. And we're using these 2 points to help us out. So now they want the slope from where x equals 1 to where x equals 2. Well, that means I have some point where it's 1 comma something, and then another point where it's 2 comma something. I just don't know what those somethings are. Well, in my picture, if I find 1, positive 1 on the x-axis, that's right here, my parabola is at 1 comma 0. So I'm going to put a 0 there. If I go to positive 2, my parabola hits it at 2 comma negative 1. So those are the 2 points I'm really looking at. This one and this one. Okay, now I can do one of 2 things. I can figure out the slope by just looking at the picture. Remember, we read a graph from left to right, so this direction, like that. So I'm going to start at this point. Rise tells me up or down. So to get from here to here, I have to go down 1. So that's negative 1. And then I go right 1. So that's a positive 1. So my slope is negative 1 over 1, or I can just reduce that to negative 1. That's one way you can do it. You can look at the graph and figure that out. And you can even tell from here to here, that's a downward slope, so it must be negative. You could also do an alternate way. You could use this formula, y2 minus y1 over x2 minus x1. That's the slope formula that you learned probably back in middle school, maybe even elementary school. I'm going to label my points here. I have x1, y1, x2, y2. And then it's just a matter of plugging in. Just be really careful with those negatives. So I have negative 1 minus 0 divided by 2 minus 1. Looks like I'm going to get the exact same thing, negative 1 over 1. So there's my slope for that one. Feel free to rewatch this section if you need. If you're a little confused on something, try just listening to it again. It's a pretty short session, so it wouldn't hurt. Okay, and then, oops, you've got 1 down here and then 2 on the back. Those are assigned to you for homework, so make sure to do those. They did get checked in class, so make sure to take care of that. Feel free to ask your teacher if you need any help.